Imagine you're heading up north. You start your car, your hands grip the steering wheel, and you start to drive. You're on the highway going about 100 kilometers an hour, and all there is to see is the open road and pine trees. When all of a sudden, when you wake up in the hospital, the doctor tells you that you were in a serious accident and there was severe trauma to your spine, leaving you paralyzed. However, the doctor tells you about a new intervention that could potentially help you to control machines just as you did before. While still in development, it has groundbreaking potential. Introducing brain-computer interface. Brain-computer interface is a general category we use to term systems that allow direct communication between the brain and an external device. Normally, when we want to control a device, let's say our phone, we have to use our brain to send signals through the nerves to reach the muscles in our hands and arms to execute the action. However, brain-computer interfaces override the step of having to use muscles to control a phone. Brain-computer interfaces can have many applications, but one of the most prominent purposes is to support people with limited control over their muscles and bodies. Let's take a look at an example. Thomas Oxley and their colleagues conducted a study where they implanted a novel stentrode brain-computer interface into the motor cortex, the part of the brain responsible for movement. These BCIs were placed in 2 amyotrophic lateral sclerosis patients, also known as ALS patients. This device is a small, flexible metal mesh tube lined with 16 electrodes that integrate with blood vessel walls. These electrodes pick up electrical signals from the motor cortex when the patient imagines moving a part of their body. The signals are associated with attempted movements and are then sent to a decoder that initially filters out the signals. Since not all the signals are associated with movement, the decoder focuses on a specific frequency, typically 12 to 70 Hz. The machine is also individualized and programmed to recognize specific signal patterns and frequencies associated with different movements, such as moving your arm. These signals were converted into a click or a zoom command for a computer. Once the device was implanted into the patients, they were connected to a computer. They were able to type up to 20 characters per minute on the computer and accurately click 92% of the time on the computer screen. They were even able to complete everyday tasks like emailing people and conduct online shopping. In a similar study, researchers implemented a BCI to convert neuron signals to speech. Each patient had 4 microelectrode arrays implanted into their left precentral gyrus, a brain area responsible for controlling speech muscles. Just like the previous study, the signals were processed and analyzed to predict the sound the individual was trying to make. For example, sounds like B and ah were predicted based on the frequency of the signals. Once these phonemes were detected, they were assembled into words and displayed onto a screen. The study found that the BCI was able to detect over 125,000 words, with a 97.5% accuracy when patients were participating in a full conversation. From these 2 papers, the condition of the patient does not matter, whether it's a condition from birth or gained through an accident. As long as the patient's brain is still functional, the BCI is able to pick up the brain signals and convert it into speech or computer movement. Although the results from these studies are promising, we have to note that these devices are not accessible to the general public and are still being tested on for further development and improvement. For example, the decoder is not widely applicable to everybody because it requires programming to recognize the signal patterns and frequencies associated with each type of command, and these may look different for each person. Thus, individually programming a BCI for each patient may not be feasible or even impact the application of this groundbreaking technology. With continued research and innovation, brain-computer interfaces can create a future where our thoughts alone can power technology and reconnect individuals with the world around them. It is only a matter of time until BCIs are implemented into the everyday lives of many people, maybe even you.